Hi, my name is Jacopo, and in this video, I will be quickly summarizing the results from my honors project, where we assessed the utility of field-deployed acoustic recorders to detect and monitor invasive chital deer. So as wild populations of chital deer are growing in North Queensland, they have begun threatening local agricultural industry by competing with cattle for forage during droughts, acting as potential vectors of disease, and contributing to soil erosion. Therefore, it is becoming increasingly important that we have methods to quickly contain the spread of chital deer, and to do so, not only are effective methods of control required, but also efficient monitoring tools that help managers decide where to allocate control resources. Currently, camera traps are used to detect and monitor deer. However, they provide limited detection areas, and their field of view can be easily obstructed, for example, by quickly growing grass during the wet season, which limits their effectiveness. Alternatively, because we know chital deer vocalize, we can use acoustic recorders deployed in the field to record environmental audio continuously, and then with artificial intelligence, we can quickly search the audio for the deer's calls. Because audio can be recorded from all directions at great distances, acoustic monitoring has the potential to outperform camera trapping for the detection of chital deer. So we collected 4,478 days, or more than 12 years of audio at Spyglass Beef Research Facility, located about 115 kilometers inland from Townsville. And our first aim was to create AI acoustic recognizers to search the collected recordings for two chital deer call types: the chirp call, which is shown in orange on the right, and the rut call, shown in blue on the left. This was very successful, and our recognizers were able to correctly identify chital deer vocalizations more than 95% of the time, meaning we could automate the detection of chital deer calls within raw environmental audio. Next, we aim to define the peaks in calling activity for chital deer. Identifying these periods is important for determining when acoustic recorders should be active. Continuous 24 recording requires excessive data storage and reduces recorder battery life. Instead, scheduling recorders to operate only during periods of peak chital activity can greatly improve efficiency. So we found chital are most vocally active at night from about 10 p.m. to 4 a.m. And therefore, to detect chital with acoustic monitoring, recorders should be scheduled during this period. Next, we wanted to directly compare the probability of detecting chital deer using camera traps, which were deployed alongside the acoustic recorders, versus the actual detection probability with acoustic recorders. So this graph shows detection probabilities for camera traps in orange, acoustic recorders targeting the rut call in dark blue, and acoustic recorders targeting the chirp call in light blue. It is important to note that camera surveys operated continuously over a 24-hour period, whereas the acoustic surveys were only during the 6-hour period defined earlier at night from 10 p.m. to 4 a.m. What this graph shows is that targeting the chital deer rut call using acoustic monitoring substantially outperforms that of camera traps from April through July. And overall, our results indicate that acoustic monitoring holds strong potential to support the management of chital deer and the protection of North Queensland rangeland systems.